I would like to build an RF attenuator box. To that end, I bought a box. There's the dimensions, you can see about how big it is. And I bought 2 attenuators. So the box is black and there are the dimensions. It cost me, say $18. The attenuators, and I bought 2 of them, are each capable in 1 dB steps of reaching 30 decibels of attenuation. They were $40 a piece. This is a pretty good deal, really. I looked at eBay last night and they're still available. I bought these months and months ago. So the box, there's nothing to it, it just looks like a box. The attenuator looks like this. 10 dB steps up to 20, and then 1 dB steps. I don't have the knob tight. From 0 to 10. So I can go 0 to 10. When I'm set at 0, I can go to 10 dB, another 0 to 10, 20 dB, 0 to 10. So that gives me 30 dB in 1 dB steps, and I have 2 of these. I've drawn a front panel, and I've drawn a interior of the box. Because of the box height, I'm going to have to mount these so they lay that way or this way. They won't mount vertically, but these are infinitely adjustable to allow for that situation. There's no flats on these shafts. These knobs are solid aluminum, and they have 2. And they have 2 opposing set screws. They're not really opposing. Anyway, there's sufficient set screws to make it not slip on the shaft. First thing I'm going to do is cut out this and use it as a template to center punch all the holes in the front panel. Then I will cut this out and attach it to the front panel. That'll become the labels. I intend to bring RF into the back of the box via Bnc bulkhead and come up here to an SMA bulkhead. Be another SMA bulkhead, and then a cable that goes to attenuator 1, attenuator 2, and then an SMA by Bnc comes out here. That means with an SMA jumper, I have a box capable of providing 60 dB of attenuation. I can insert a fixed attenuator between these 2 SMA connectors, and then I can get any attenuation. It's still variable in 1 dB steps. I intend to assemble the box, hook it up to my RF generator, set the attenuators at 0, and measure the output. Then I'll put that number here in decibels. Really dBm. I think it's going to be around 10, maybe 9. And so the output is this number to be filled in, minus the attenuator value here, if any, minus number 1 setting, minus number 2 setting. These attenuators are either still in production or they're still new enough to have documentation available on the web. This was last updated in 2015. So I have dimensions. This shows Bnc connectors, but obviously they're available in SMA. Here's the inside of the attenuator. 2 attenuators, a front-mounted Bnc connector to here, from here to here, from here to an SMA jack, and from the upper SMA jack, I need to drill a hole in the rear panel. We'll go this. So this will be in a jumper, an attenuator, a second attenuator, and out. Everything fits in nicely. So I'll put a front panel on this and button it up. This VFO signal generator has 6 low-pass filters. I showed the winding of them and the switching board. And they're 0 through 5. Bandpass filter 0 is a 60 meter low-pass filter with a cutoff frequency of 5 megahertz. It's installed on the main board of the VFO. 1 through 5 are installed on the relay switching board. Now they're sort of out of order here. If I desire to produce a frequency below 5, this filter is switched in, and these are all switched off. Between 5 and 7, this low-pass filter is switched on. As soon as I go above 7, this is switched off, and this one's turned on. Above 10, this one's turned off, and this one's turned on. 14, the same thing. If I go above it, this one's turned off, and this one's turned on. And above 21, this one's turned on. The problem is that with the jumpers, or maybe it's the board, this one is always on. Now this 50 megahertz low-pass filter doesn't do a damn thing down at these lower frequencies. At least that was what I thought. What it does is prevents me from going above 35 or 40 megahertz. It begins to fall off at 30. You can stop and freeze this to read it, but if you set the band limit to 30, then any operating frequency higher than 30 megahertz, none of the relays will be activated. That's not true. The reason for this is because the oscillator board was designed to be used as a low-power transmitter. And it played by this rule. Independent testing of the band spectrum indicated that they had a problem at the high end with second and third harmonic presence. So they redid the jumpers or the board to make filter 1 always in the circuit. We'll take a look and you see what that does. I'm looking at the output of the attenuator box. The VFO is set to step at 100 kilohertz. Okay, see what happens below about below about 2 megahertz, it begins to become distorted. That is the second and maybe third harmonic leaking through the 5 megahertz filter. Once we get above about 2.5, I'm at 3, 3.5, 4, 5, 6, 7, 8, 9, 10, 11, 12, 15, 20, 25. So there's 30. Now watch what happens. It'll begin to drop. And you see there it begins noticeably about 31 megahertz. And then at 40, you know, we're down into the noise. I'm going to call it calibrated between 30 and 4. Now that drop off above 30 megahertz is due to the fact that low pass filter number 1 is always in the circuit. I've got the attenuator box and the VFO stacked. In fact, they're held together with double-sided tape. Now, I programmed this second line. You can't see it, but right above my finger is a blinking heart. It blinks once a second and tells me that the GPS system is functioning. Right now we're picking up 9 satellites, or at least there's 9 satellites being used in the computation, the algorithm that corrects the frequency. And here I've elected to show the relays that are in operation. Now we'll lower the frequency and see at 21 megahertz, when I go below it, relay 2 comes in, and we go down here to the next one. (14 megahertz). (10 megahertz). 6 megahertz. Pretty quickly there. 4, 5 megahertz, I guess. Now relay 0 is on forever until the frequency generator stops. When we go up above 30 though, which is where relay 1 should deactivate, it remains on. And of course, being that relay 1 is a 30 megahertz low pass filter, the output at all the higher frequencies becomes nothing. Now I'll hook it up to my spectrum analyzer and decide what number to enter in this box. Well, I have the camera set up. This is a unit I want to replace. It's a Bnc, it's all solid state, E2000 signal generator. Now it goes up, I guess it goes up to 200 megahertz. But that's on harmonics. The primary frequency is 0 to 50, something like that. It has a level setting meter and a whole bunch of attenuators. There's a 6 dB step and a 30 dB step, a bunch of 20s and a 10. So that I can and had thrown in all those attenuators like the look at the front end of a radio for sensitivity. This is a very nice generator. It's not very stable. It has a crystal calibrator. I think it's 100 kilohertz, or maybe one. It's double shielded. The only thing I did to it was to put a BNC here. Used to have what we used to call, I think, a Motorola jack. I'm not sure that's right. And what you would do, it has a audio output, and you would set this at a multiple of the calibrator, and then by rotating this little knob, you could vary the pointer. So you would adjust the line, adjust this for 10 or 11, and you could modulate this with an internal AM 400 hertz signal. It served me very well. If you have a chance to get one of these, I would get them. I have a subdirectory full of all kinds of information about it, which I'll try to link at the bottom of this video. But the new BFO and attenuator should be as well shielded as this, and it's much smaller and much more accurate, hopefully. While we're doing this video, I want to show you something. Here's a nice Bnc connector, and the only thing you would see is this round rim if it were installed in a bulkhead. It is a bulkhead fitting. The nut and lock washer go up here. The only way to get it into a panel is to get these fittings off, and you can't do it. It can't be done. Now the hole in the back of this VFO, in order to accept a fitting like this, needed to be enlarged. So I had to drill this out to 1/2 inch. Well, I just powered up my spectrum analyzer, and it has no vertical sweep. Yesterday it worked fine. This doesn't bode well. So I need to tear the spectrum analyzer apart.